Welcome back to Math for Technology. We are moving on to section 2, values of the trig functions. In the last section we worked with a right triangle on a coordinate system. We were starting in standard position with the initial side on the positive x-axis, and the terminal side could move around with the vertex being at the origin, so like clock hands. Now we're going to take the right triangle off and we can work with it anywhere we want. So I have a basic blank right triangle. We're still working with theta being our focal point, and I'm going to put it down here for right now. And what we were working with is that we had an x and a y and an r. So x was always what it would be on the x-axis, y moving up or down on the y-axis, and then we used r as the distance from the vertex or the origin out to our endpoint. That works great when we're on a coordinate system, but we're not always going to be. So we want to use some different words to help us with that. So if I'm working with the theta here as my angle, which it is, this x is next to it or adjacent to it. The y is across the triangle from it, so it is the opposite of it. R, remember, is what we call the hypotenuse because it is directly across from the right angle. So we're going to move from using x's, y's, and r's to moving adjacent, opposite, and hypotenuse. And why this is important is before our theta was always down here by the origin. Now our theta might not be. We could potentially have our right triangle, and instead of being up on the or down here by the origin, maybe we're standing up here, or we're positioned where our angle is up on the top of the triangle. This still would be the hypotenuse. That's not going to change since it's across from the right angle. But since I'm positioned at this angle, if I go across or opposite of it, now I am positioned down here on the x-axis. And this would be over here. Next to it would be adjacent, which would be on the y-axis. So I want to be able to move to different parts of the triangle, and my opposite and my adjacent, they change because of that. So we're going to look at our trig functions that we'd already talked about in terms of x, y, and r, and now we're going to move them in terms of y, or in terms of opposite, adjacent, and hypotenuse. So sine was in terms of y and r. So if I still look at this triangle and think of y and r, now I'm going to use the terms opposite and hypotenuse. And I'm going to go ahead and abbreviate it. Cosine was x over r. That would be adjacent, and I wrote that one upside down, I just realized. I'm going to back up and erase that. This one is opposite over hypotenuse. My apologies for that. Adjacent over hypotenuse. Tangent was opposite, or was y over x. Y is opposite, x is adjacent. Now if you can remember, cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent, so I can take these terms and just flip them upside down. I'm hypotenuse over opposite. I'm hypotenuse over adjacent. And I am adjacent over opposite. It would be helpful if you could memorize at least the first three trig functions, sine, cosine, and tangent. Reciprocals you can always just flip. There are many ways out there that you can do that. The most famous way of trying to remember this is the term SOHCAHTOA. The idea here is that the sine function, which is the s, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. If you look up ways to memorize these trig functions, there's also some sentences out there that people have come up with. One is, some old horse came a-hoppin' through our alley. And there's many other ones, some very colorful ones. to try and help you memorize this. So find a way to keep that in your memory. Let's apply what we just were talking about here. So I have an angle theta. I want to find all 6 trig functions. I know that A is 5, C is 13. So if we think back to the Pythagorean theorem, C is always our hypotenuse. So I'm going to draw a right triangle. C is 13. Doesn't really matter who A and B is. I'll just make AB 5, and then I don't know this one. So I am going to have to use the Pythagorean theorem to find this other side. 5 squared plus b squared equals 13 squared. That's 25. That's 169. Minus my 25 gives me 144. Therefore, b is 12. I'm going to place my theta. So I want to think in terms of opposite, adjacent, and hypotenuse now. So 12 is next to my angle, so it is the adjacent. 5 is across the triangle, so it is opposite. 13 is across from the right angle, so it will be the hypotenuse. Hypotenuse never changes. So sine, if I look back up here, sine is opposite over hypotenuse. Look at my theta. The opposite side is 5. The hypotenuse is 13. So that is the ratio for the sine. Cosine is adjacent over hypotenuse. Adjacent is 12. Hypotenuse is 13. Tangent is opposite over adjacent. Opposite is 5. Adjacent is 12. So there's those 3. The other 3, we simply have to flip these upside down. Sine is the reciprocal of cosecant. So that becomes 13 over 5. Cosine is the reciprocal of secant. Becomes 13 over 12. Tangent is the reciprocal of cotangent. 12 over 5. So I can find any of the 6 trig functions just knowing 2 out of 3 sides of a right triangle. This one, what they've done with us, to us, or for us, is they've given us a trig function and a ratio. Based on what we know about cosine, we can place it on the right triangle. Cosine, according to our chart, is adjacent over hypotenuse. So 8 is adjacent, 17 is hypotenuse. I'm going to go ahead and draw a right triangle. Definitely need to work on my right triangles. They're getting worse and worse. Okay, that's driving me crazy. Let's get rid of that. Try again. A little bit better. Put our theta in here. Everything is related to your theta. Adjacent, opposite, hypotenuse. I know, based on what they told me, that the adjacent is 8, so this side is 8, the hypotenuse is 17. First thing I have to do is find the opposite side with the Pythagorean theorem. 8 squared plus b squared equals 17 squared. 8 squared is 64. $17 squared is 289 minus the 64. B squared is 225. Square root of 225 is 15. My opposite side is 15 units. From that, I can now find the other 5 trig functions. Sine is opposite over hypotenuse, so that is going to be 15 over 17. I already know cosine, but I'm going to go ahead and write it down. It'll help me when I go to do the other 3. Tangent is opposite over adjacent, so that's 15 over 8. Now to do the other 3, I just have to flip. Cosecant is 17 over 15. secant 17 over 8. Tangent is cotangent 8 over 15. So now I know how to find my trig functions either based on I'm given two sides, like in example 1. I could be given a ratio for one of the trig functions, like in example 2. It doesn't have to necessarily look like that. Maybe, like in example 3 here, instead of giving us the ratios in a fraction, they give us the ratios in a decimal. So instead of trying to turn them into fractions and then place them on the table or on the right triangle, it would actually be easiest to use what we call identities. So these are 5 of the identities that we're working with. There are many more and many that we'll never touch on. So you might have seen some trig identities if you've taken some other math somewhere else. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. That makes sense because those are reciprocal functions. Tangent can also be related as sine over cosine. Cotangent can be used as cosine over sine. So we're going to use these identities to help us find the 4 that they don't give us. We know sine and cosine. And I always just get in the habit of making all 6 of them written out every time. That way I have them organized and ready. So the next one I'm going to try and find is tangent. So I look up here at my identities and I say, okay, I know sine and cosine and I need tangent. Well, here's an identity that uses sine and cosine when I know or when I'm looking for tangent. So I'll do my work over here. To find tangent, I'm going to take sine, which is 0.866, and I'm going to divide it by 0.5 because that's what cosine is. 0.866 divided by 0.5 gives me 1.732. So that is now my tangent. To find the other 6, I'm still going to flip. Flipping is just taking 1 and dividing it by my answer. So to do cosecant, I'm going to do 1 divided by 0.866. And if I round it, I get 1.15. Secant is 1 over cosine. 1 divided by 0.5 is 2. Cotangent is 1 over tangent, so 1 over 7.32 is approximately 0.577. I now can have all the other 4 trig functions given sine or cosine. So I will use these identities that were given here, these 5, to help us with that. Let's try that again. This time we're given cosecant and cosine. First thing I see is I have sine. Sine is, what do I know about sine? Sine and cosecant are reciprocals. Now, they gave me cosecant, but it is the reciprocal, so I can actually do this another way. I could say that sine is 1 over cosecant. So I could go 1 over cosecant, which is 4.872. 1 divided by 4.872 is approximately 0.205, so I know sine. They had already given me cosine. We know that is 0.979. I now need tangent, and again, I just tend to do it in this order so I don't forget anybody. You can definitely do it in any order that you feel like. Tangent, if I look up here, is sine over cosine, and I actually know both of them now. So now that I know sine over cosine, I can take the answers, 0.205 and divide it by 0.979, and I know that tangent is approximately, because I am rounding, 0.210. So I have sine, cosine, tangent. I need still cosecant, secant, and cotangent. Cosecant was given to me, so I don't have to find it. It's just the 4.872. I do need secant. Since secant is the reciprocal of cosine, we'll do 1 over 0.979. Rounded, it's 1.02. Cotangent is the reciprocal of tangent, 1 over 0.210. It is going to be approximation because I was rounding that other number. Oh, and I don't know why. Cotangent is the reciprocal of tangent. Oh, I grabbed the wrong number. I was like, that is not the answer. 4.77. It's very close to cosecant, which is why I paused for a minute. And it's because if you look at tangent and sine, they're also very close to each other. Okay, so we have all of the trig functions, the 2 that was originally given to us, and then the other 4. Now this last section is really just how do we use the calculator. I'm not sure what type of calculator you're using, if you're using an online calculator, if you have a scientific calculator or a graphing calculator. You do have to just know your calculator. I'm going to go ahead and just do this with a basic scientific calculator. They are the cheapest. You can buy them for $5 to $10. So I'm going to go ahead and turn this over. It doesn't need to be. So I have a calculator here. You have the paper in front of you. So I'm going to go ahead and turn that on. Sorry if you're getting seasick for a moment. Okay, so the first question they ask us for is sine of 29.7. In my calculator here, see I have this DEG right here. That tells me that I'm in degrees. So I'm going to go ahead and do all the degree ones first. I'm going to clear this out. So 29.7, on this calculator I have to plug in the degree first, and then I just hit the sine button, and then there's my answer. So I'm going to go ahead and write down 0.495. And I'm actually going to go out 4 numbers, 4955. The kind of the rule of thumb in these is to go ahead and do 4 decimal places when we're dealing with trigonometry. The next one is cosine of 20 degrees 15 seconds. We saw that back in the first section. So when I'm dealing with that, what I'm going to do is, again, we're going to put in the degrees first, so 20, but what I have to do, because it's in seconds, and this calculator does not have that, I'm going to do plus 15 divided by 60, because there are 60 seconds or 60 minutes in a degree. So now I'm to the decimal of 20.25. I'm now going to just do cosine of that. So 9382 is my answer. So let me write here what I did. I did 20 plus 15 divided by 60 to get the decimal of 20.25, and then I did the cosine of that. The next one is cotangent of 93.7. As I'm looking on here, notice there's no cotangent, but we have reciprocals. So what you have to do first is cotangent is the reciprocal of tangent. So I'm going to do 93.7 tangent, and then I'm going to flip that upside down. On this calculator, this is the reciprocal button. Some calculators, it's an x to the -1 button, so you'll have to find that. When I push that, it flips it upside down for me, so it's -0.0647. Shows you sometimes they can be negatives. 0.647. These last 3 are actually in radians, and so you have to figure out how to turn your calculator into radians. This calculator, and many like it if you're just using a scientific calculator, it's the DRG that's changing it. So right now it's in degrees. When I clicked right there, The little top said it went to RAD, so now it's in radians. All I have to do is go 0.25 and hit the tangent button, and there's my answer, and I'm already in radians, so it took care of everything for me. That is approximately 0.2553. Secant of 1.35. You have to think, who is secant the reciprocal of? Secant is the reciprocal of cosine, so we're actually going to do cosine. And I didn't get all my numbers in there, so let's get those in there. So I'm going to do cosine, and then because I need the reciprocal of it, I'm going to do the 1 over x. So 4.566. And my last one is cosecant of 1.555. Cosecant is the reciprocal of sine, so I do 1.555, then I do sine, and I go ahead and flip that over, and it's pretty much 1. There's just that tiny bit on the end. But I'm still going to put approximately, because it wasn't exactly 1, I did round it to that. So this lets people know it wasn't exactly 1. So for this section, which is the last section in this assignment, all of this will be calculator based. If you need help with your calculator, I would try Googling it. If you can't, if you're really stuck and you need some more help, give me a holler, give me an email, and I'll see what I can do. Have a good day.